Managing money, savings plans. Suppose you want to save money, perhaps for retirement or for your child's college expenses. You could deposit a lump sum of money today and let it grow through the power of compound interest. But what if you don't have a large lump sum of money to start such an account? For most people, a more realistic way to save is by depositing smaller amounts on a regular basis. For example, you might put $50 a month into savings. Such long-term savings plans are so popular that they may have special names, and some get special tax treatment, including individual retirement accounts, or IRAs, 401k plans, and the 529 college savings plan. To keep the numbers simple, suppose that your savings plan pays interest monthly at an annual rate of 12%, or 1% per month. We are going to assume that you begin with $0 in the account, and at the end of the first month, you're going to make your first deposit of $100. Then, at the end of month 2, you receive monthly interest on the $100 already in the account, and you make your monthly deposit of $100. Recall that simple interest is I equal to PRT, and we see at the end of that second month you will have earned interest of $1 on the $100 already in the account. Your total balance at the end of month 2 is then $201. At the end of month 3, once again, you receive monthly interest on the $201 already in the account, and you make your regular deposit. The interest at the end of month 3 would be $2.01, bringing your total balance at the end of month 3 to $303.01. In principle, we could extend this table out indefinitely, but it would take a whole lot of work. Fortunately, there's a much easier way. We will call this the savings plan formula. Here's the savings plan formula. Let's get familiar with the different parts. A is the accumulated savings plan balance, or the ending balance or future value of the account. PMT is the regular payment or deposit into this account. APR is the annual percentage rate or interest rate on the account. N is the number of payment periods per year. Y is the number of years holding the account. Note that this version of the savings plan formula assumes that the same periods are used for the regular deposits or payments and compounding. For example, if payments are made monthly, interest is then also calculated and paid monthly. We will use the built-in TVM solver function to assist us with these calculations. This class is just as concerned about the interpretation of the solution as well as getting the numbers correct. For this reason, let's take a look at first how to find the TVM solver on your calculator and then take a look at the different inputs. On your TI-83 or 84 calculator, we're going to click the Apps button. Select the first option to get into the Finance section. Select the first option again to enter the TVM Solver application. Here is the home screen that we will be using in the TVM Solver application. Let's take a look at the inputs for any desired problem. N is the total number of compounds in the account. I is the interest rate or the APR or the annual percentage rate on the account. Note that in this application there's no need to convert a percentage to a decimal. Use the percent number when inputting your annual percentage rate or the interest rate into the TVM solver. PV is the present value or beginning balance of the account. PMT is the regular and reoccurring payment or deposit into the account. FV is the future value or ending balance of the account. PY is the number of payments or deposits per year in the account. CY is the number of compounds per year in the account. Remember, PY and CY will remain the same for this class. Let's take a look at an example. Use the savings plan formula, in our case the TVM solver, to calculate the balance after 6 months for an APR of 12% and monthly payments of $100. Here we are looking to find the future value, meaning the ending balance after 6 months. We should be able to input values for all the other inputs. Since we are making monthly payments over the course of 6 months, N is 6, the interest rate was 12%, the present value would be 0 because there was no initial balance in the account, the regular and reoccurring payment was $100. We don't know the future value. Remember, the future value is the same thing as the ending balance, so we're going to put 0, but come back to that in a second. PY and CY are the number of payments and compounds per year. So since we're making monthly payments and we assume that the number of compounds would be monthly as well, those values are going to be the same at 12. Since we are looking to find the future value, let's go back up to that FV input. In order for the calculator to solve for the future value of this account, slide the cursor back up to the FV input and hit alpha, solve, in order to get our solution. The balance after 6 months will be $615.20. You may wonder why the result is negative on the calculator. This is an artifact of the way this financial calculator handles cash flow. Positive amounts are considered inflows of money and negative amounts are considered outflows. In this case, the positive monthly payments of $100 are inflows to the savings plan. The future value is then negative because this is the amount you will eventually draw out of the savings plan at some future point in time. In this class, we will not concern ourselves with cash flows. Simply disregard the negative sign for now. Let's take a look at another example. At age 30, Michelle starts an IRA to save for retirement by depositing $100 at the end of each month. If she can count on an annual percentage rate of 6%, how much will she have when she retires 35 years later at the age of 65? Monthly deposits over the course of 35 years means there will be a total of 420 deposits made into this account. The interest rate was 6%. The present value or beginning balance is 0. Again, it did not mention a beginning balance to this account. Her regular and reoccurring payment was $100. We don't know the future value, so we'll come back to that. And since we're making monthly deposits, the number of payments and compounds are going to be 12. Again, 12 payments per year, 12 months in a year. Slide back up to the future value input, alpha solve, and we see the balance when Michelle retires in 35 years will be a future value or ending balance of $142,471.03. We can take these problems one step further and discuss how much interest was earned on this account. Michelle contributed $100 per month over the course of 420 months. Michelle then contributed $42,000 to her retirement account. If we subtract this amount away from the future value or the ending balance of the account, we can see, thanks to compounding, Michelle's retirement account will have earned her roughly $100,000 in interest over the 35 years. The only two things that are going into this savings account are interest and the regular deposits. Let's take a look at another example. At the age of 24, to save for retirement, you decide to deposit $40 at the end of each week in an IRA that pays 4.5% compounded weekly. How much interest was earned on this account if you retire at the age of 65? You have this account for 41 years, making weekly deposits, meaning in total, there's going to be 2,132 deposits into this account. The interest rate was 4.5%. Present value is 0. Again, there was no mention of a beginning balance. The regular and reoccurring weekly payment was $40. And again, the number of payments or compounds per year would be 52 weeks in a year. Slide back up to the future value input, find the ending balance, hit alpha solve. Remember, this is the ending balance of the account. We were looking to figure out how much interest was earned, so first we need to figure out how much we actually contributed to this account. Subtract that away from the future balance, and we see that you earned $160,763.33 in interest on this retirement account over the course of 41 years. Most people start savings plans with a particular goal in mind, such as saving enough for retirement or enough to buy a new car in a couple of years. For planning ahead, the most important question is this: given some financial goal, what regular deposits are needed to reach this goal? Take a look at the following example to try on your own before moving to the solution on the next slide. When your child is born, you set a goal of building a $100,000 college fund in 18 years by making regular end-of-the-month deposits into an account. If you can safely assume an interest rate of 3%, how much should you start depositing monthly in order to reach this goal? Making monthly deposits over the course of 18 years means there's going to be 216 deposits at an interest rate of 3%. Present value is 0. Again, you didn't start with any money in the account. We don't know the regular and reoccurring payment. That's what we're trying to figure out. We know the future value or the ending balance, our goal, is $100,000. And again, we're making monthly payments and monthly compounding 12 months in a year. Slide back up to the regular and reoccurring payment, hit alpha solve, and we see that you will need regular monthly deposits of $349.72 to reach your savings goal of $100,000 for your child's education in 18 years.